Okay, so this is 2011 B3, quick look at it. So everybody can get damage done because it was straightforward. So you had to set up a 55-degree angle here. So 55-degree angle going up there. Leave that light for a second. Then you got to project up the center to here, and I now want to go down at 70 degrees. So really what you got to do there is, well, there's a couple of ways of doing it, I guess. So the angle there is 70 degrees from level with this. Okay, so if I take a horizontal across, so that is the left hand side, going up to there, and I need a 70-degree angle now from there. So the easiest way to do this is just put a 70-degree angle anywhere. So I'm going to just work off this dot here. So line up the protractor, get a 70-degree angle, so that light line here is a 70-degree angle. I'll just heavy in a little bit, and I'm going to just use sliding set squares there then to do that angle parallel from here, going through here. So that there is our 70-degree angle. And there's the front view, top view, and then now that you know where this line is going along here, you can project that down to the top view. So there's our front view finished and our top view finished, which is A was to draw the given elevation and plan and project an in view in the direction of arrow A. Okay, so an in view in the direction of arrow A. Okay, so I should have put that over there, but what I will just do there is by putting the XY line in this direction. So I'm going to put my 45-degree line in that direction there, and that's going to have the same effect as looking in from this side. So bring over and up. And there's a couple of easy enough points here, because if I'm looking this way, like so, that's the left hand side, that's the right hand side, and this would be the middle looking this way. So I'll project all of those up, and that's cut horizontally along here. So if I wanted to know, maybe I do, I'm going to find the line along the top here first. So that top edge there on the lipstick is basically here. That is that top edge here. And I also know then that, let's say this is the center line. I'll just heavy that in a tiny bit. That's the center line running up here. So that's going to be like the widest part of the ellipse. So So I'll project that across there, and that's where the sides are gonna be going heavy up to that. So that's the straight sides going up there. Now what I'm going to be left with here now is a curve. There's going to be a curve now coming up here and going up there then to the top, but from here, because this is the end of the major axis of the ellipse, or the bottom of the curve here in this. Now there's a few ways to do this, but I just put a bit of colour on it because it just makes life easier. So if I just picked a couple of random widths here, so I'm just going to go with 1, 2, 3 to get a fairly accurate curve. If I bring them down to plane, so that would be width 1 and width 2 and width 3. And I've already done width 4 there, and maybe I should take one more then over here. So I'm going to call that 1, 2, 3 and 4, and down here that's 1 and 2 and 3 and 4, like that. So I can take now those across. Now I could bring them over and up, but there's a lot of drawing and it gets messy to bring their widths across and up. I would rather use my compass, and because that's a point view of a line, that green line here is a true length in the looking down on it, so that is the real width of 1. So I can mark it. So they're my 2.1s. I'll just dot them in there in green just to help you understand it. And the same then with all the rest of them. The 2.2s. Okay, so they just happen to coincide with this. And the 0.3s. And finally it's going through, that's the full minor axis, and then finally 0.4s up here then when it's coming back in. So my curve then is going like this. Just going to double check that there now. And that there then is the width of the top. So you can see, yeah. Oh, that one is just out a tiny bit there. So my curve there then goes so that there is the sloping curve. Now maybe you'd understand it better if I heavy these lines in green, even though I don't particularly like doing this, but it might make it easier to understand it. So there are those lines that I use down here. And now going down the back there then, it's cut, there's going to be a dotted line coming down there from these down to there, and again I'm going to, maybe I should, no, I'll just keep going with the same thing here. Now I'm going to call that 5 and 6. So I'm going to take 2 more widths here, 5 and 6. So that would be 5. These are on the other slope now, sloping down to the left on the far side, and 6. Same method. Bring them across light. What is the distance either side of the center line? So the 5s are here. The 6s and that's the hidden curve going down the other side. So I'll put that in dotted. And and that there is front view, top view, side view. Now ideally the side view should be over here, but that is the correct view of it by putting the 45-degree line going the other way. So we're still but it is in the wrong place. And finally, draw the true shape, or sorry, next then was draw the true shape of the elliptical cut surface S. So the true shape of surface S. So this here is surface S. Now there's a few ways to do this. There's a few ways to do it. I could rotate this up here. I could rotate this up with my compass, and I'm going to just talk about this for a second. So I could stand that up straight, rotate it up here vertically, and so it would be vertical up here, and project across. I could do that, or I could take an auxiliary. There's so many different ways to do this. I think I will actually do that, even though it's a tiny bit. No, it's too messy though. No, that would annoy me to do that. No, there's another way I could do it. Really quick way would be because that's the minor axis and the major axis here of this. I could draw it like a normal ellipse. And I could do that, so I'm just going to check what part C involves. The elevation of the okay, so yeah, I've loads of room over here. So what I'm going to do here is I'm going to just rotate that up and project it across, and I'll draw the true shape up here, but I'm going to move it out beside it. Now the easiest thing would be to put it on top of it here, but that would just be a bit messy. So here is going to be the major axis of that ellipse, and again I don't have to do this, but just to help you understand, I could take these distances from here and not bother rotating them at all, but look, I will rotate it just to help people understand what is actually going on here. So if I rotate all these widths, I'll just use a colouring pencil here now to say that this here is the edge view of surface S. I'll put that in yellow. That's the edge view. Of S. I'm going to bring all those points across now. So there's point 1, point 2, and I'm bringing them off the rotated surface where they're standing up vertically. And there's the top. And I can again use these real widths from down here, or I can take them from here. Doesn't really matter. I'll just take them from here, I guess. So the real width of 1 is that, which is also can be got from here. But I'll stick with the very first place. Now I drew them, that's usually the most accurate. So the real width for 1 is there and there. Real width for 2. So it's often best to work off a center line when it's symmetrical. There's 2. Three. And I could have, for accuracy's sake there, now I never rotated over the center point, and I probably should have to be really accurate, because this is the widest part of the ellipse. So even though that doesn't have a number, I'll bring it across there. This is the widest part, the minor axis in other words. So that's my minor axis. And finally the top of it up here then, which is, it doesn't have a number really. That's the top width here. Oh yeah, I forgot 4. So that there. That there is the true shape. But really, just to go back to, like, I could also have done it, because there's no whole point to this question, I'm going to look at another way of doing it. So I could have taken the major axis from here and decided I'm going to draw it here. So this is the major circle and this is the minor circle for that ellipse. And this would also have been perfectly right. Divided up the usual concentric circles method. So 2 at the time. That here is our ellipse, but we don't want a full ellipse, so I just want to put on the brakes here in a second. I'm not going to draw all of it, but I'll draw the light. Okay, so there's our ellipse, but it's cut. It only goes this far past the center. Okay, so it only goes that far past the center. And I'm chopping the rest of it off there then. So really, the rest of that is going again. suppose I shouldn't have heavied it in the first place. And that there is just another way of doing the same. That's the same as that. So finally, the last part of this, you're asked to draw the elevation of the focal sphere as indicated. Now look, that's basically a cut cylinder. Now if I was looking straight in at that, this is just our front view again. Okay. Right, we're putting a sphere into this. I'll put the sphere in yellow so you'll understand this maybe, but it's tangent. Okay. No, it's tangent to this surface and to that surface. So what I want to do is bisect the angle here to find the center of that sphere over here. So I'm just opening up my compass, but I want to do this now pretty big, not that it makes it more accurate. So I'm going to open my compass good and big. There. Okay, so hopefully you got most of that. It might have been off camera a little bit of when I was doing the top of this. So I'm after bisecting the angle here, and that here is the center for the focal sphere. So when I set my compass here, this is the focal sphere. Now I really so that focal sphere here, really I should put it in yellow just to help people understand this there now. That's the focal sphere. It's tangent to the cylinder, and it's also a tangent to the edge view of the ellipse here. So I just want to line up the angle here now of this, and once I get the right angle for the edge view of the ellipse, which is here, I want to go at 90 degrees then through the center of the focal sphere, and that there is my focal point. So I'm going to get a red biro there to do this. I'm actually going to put this in red. Okay, so that's perpendicular to the edge view of the ellipse here. That there is the focal point F. And if you wanted to show the other one, even though the other one doesn't exist, I don't think it does anyway. I'll just extend this out and check. Because it's symmetrical, so however far, yeah, so it's definitely not, no, it's off it's cut away. The other focal point would have been, just move this up a little bit there now. So the other focal point would have been up here. I will actually mark it in for the sheer hell of it. F and F1. So that would be the other focal point if the ellipse wasn't cut away there. So there's the focal sphere, the focal points, and I think it asks for the directrix as well. Establish the position of the focal point and the directrix for the cut surface. Okay, so the directrix is when that cutting plane there is extended out like that, and the plane then going through this, the the plane that contains the circle of contact between the sphere and the cylinder, when that is extended out to here, that there is the location of the directrix. So I'll just put an arrow there to say that that's coming out there. So I'll just put D there, DD maybe even. So directrix focal point, because if I was to go back to the 3D here, the plane that contains the ellipse and the plane going through the center of the sphere, it's where those two planes meet out here, gives us the directrix. Okay, so the directrix is there and the focal point is here. In 3D, that's basically where it comes from. Hopefully that's on camera. Just about, yeah, just about. So yeah, that there then is 2011 B3. Again, a small bit slower there because I did true shape a different way, butcher, whatever, yeah, whatever. And yeah,